皆さん、こんにちは。Ultimaker Japan の池田です。今日はお忙しいところ、弊社のショーケースにご参加いただきましてありがとうございます。今日は大阪の、WeWork 御堂筋フランティアの方から開催の方をさせていただいております。今日のアジェンダは、3D プリンティングで欠かせないスライシングソフトウェアのご紹介、スペシャルゲストスピーカー3名に加え、メタルプリンティングのソリューションのご紹介をさせていただきたいと思います。ご質問等ある方は、ぜひチャットの方にご質問を入れていただき、後日弊社のものより回答させていただきます。あと、セッション中にポップアップの質問が出てきますので、ぜひ質問の方に答えていただければ、幸いです。では、最初に弊社の最高責任者である、ユーゲン・バン・ホーレンさんからの、メッセージです。
Welcome to our Spring 2022 Ultimaker Showcase event. We're really excited about the developments we are sharing with you today. I believe that what we are announcing today is a true game changer for users of our technology. I'm pleased to have a few 3D printing experts across the design, architecture, and engineering industries share with us how our new developments impact their work. Today I'm excited to announce, firstly, the Ultimaker Metal FFF solution. We'll be talking with the metal 3D printing experts about how we have taken complex and expensive production processes and are making it much more accessible to more companies. Further, we are here to introduce the latest version of the world's most used 3D printing preparation software called Cura. It's a release that marks a major milestone in the history of Ultimaker Cura with a brand new slicing engine and other great new features. And my colleagues will show you more in a moment. But first, I want to take this moment to celebrate Cura, to celebrate the team here at Ultimaker that develops each release every day, our amazing community of contributors, and you, the many beta testers and users who send us feedback and suggestions. So because of this effort, millions of 3D prints begin life with Ultimaker Cura every month. I really love hearing customers talk about how 3D printing helps them with new developments and accelerates their new product introductions. Or even to learn how 3D printed tools and fixtures keep people safe in the factory, or even enhance the ergonomics of their factory workstations. I mean, who would intuitively connect 3D printing to the well-being of workers? Or even how 3D printed parts help production line changeovers happen so much faster than before. Who would have thought to connect 3D printing to improved machine utilization and even factory productivity? You know, the myriad of creative, inventive uses we learn about and the impactful stories we hear show how 3D printing can empower any individual or organization who wants to change their world in the biggest or the smallest way. We're talking about real, meaningful applications that improve people's lives and impact business results in a positive way. Our products are used by major brands around the world, but also by small and medium-sized businesses. But however impressive the cost and efficiency savings they can achieve, Ultimaker has always been about much more than this. We help to make 3D printing a possibility for everyone, for social, inclusive organizations who create 3D printed braille learning or working tools, medics printing prosthetics and orthotics, schools who could equip the next generation with vital problem-solving and STEM skills. You know, we're about making 3D printing a real possibility for anyone who wants to turn an idea into a physical object in their home, garage, workshop, or factory. At Ultimaker, we're all about removing the complexity barriers of 3D printing and making it easy to use, more appliance-like, and if you will, intuitive. We are focused on enhancing quality, tolerances, and finesse of your prints, and to enable usage of a wider range of materials. And we put our efforts into making 3D printing faster. To get to a better end result, easier, quicker, and more consistently, a simple but challenging formula. one that we are passionate about. We consider today's showcase event a milestone in 3D printing because we will be sharing improvements to what new and existing printers will be capable of as of today. In fact, we are convinced of this step change, that even those who have looked at 3D printing in the past and concluded that it may not be ready for their use, that today it is time for them to look again. Many of you will recognize that until now, you had to make your design work for 3D printing. It's time to turn the table from designing for 3D printing to 3D printing for design. Solutions and applications focused, user focused. In a moment, you will see some of the Ultimaker team share what we've been developing and share the benefits to new and existing users of 3D printing, opening up even more uses and applications. We are also delighted and honored to be joined by the award-winning lighting, accessory, and furniture designer, Tom Dixon, engineer and 3D tech consultant, Steve Cox, and 3D modeling expert architect, Carlos Castillo. They've had early access to the new products we're showcasing today and are ready to inspire you with their learnings and applications. So with so much exciting news to present and such inspiring speakers ready to share their thoughts, I think it's time to get started. I hope you enjoy the showcase.
Ultimaker Cura is the most used 3D slicing software in the world. With over 4 million files sliced every week and over 500 million total files sliced, we've helped countless companies, institutions, and individuals realize the magic of 3D printing. Version after version, Ultimaker Cura has continually advanced, adding new features and improvements that have helped it stay on the cutting edge of 3D printing technology, all of which has brought us to now. Get ready for a breakthrough in 3D printing with Ultimaker Cura 5. Introducing a revolutionary new slicing engine that enables you to print finer details than ever before. Join the thousands of people using Ultimaker Cura every day and discover a world of new possibilities.
はい。ヨゲンさんからのお話でした。ありがとうございます。では、本題に入りたいと思います。3D プリンティングの、世界ではほとんどの方が、Ultimaker Cura の存在をご存知かと思いますが、もしご存知でなければ、Cura は 3D プリンターが理解できるファイルを、制作するための、ソフトです。モデルを平らなレイヤーから、積み重ねていくことにより、スライサーと呼んでいます。こちらのソフトは、実は完全オープンソースであり、毎週470万回のスライスが実行されています。これは1秒ごとに世界中で5人以上の人が Cura を使用して、モデルを 3D プリンターで造形していることを意味します。どんなプリンターを使っても、初回でも簡単にプリントを成功させることができる、わかりやすいソフトです。さて、今日ご説明させていただきます、最新版の Cura 5.0 は、以前のバージョンとどう違うのか、ご説明させていただきたいと思います。簡単に言いますと、より細かく、より小さな部品の特徴を印刷することができるのです。これまでスライスをしてプリントすることが不可能だった、あるいは非常に難しかった形状をより細かくソフト上で表すことができるようになったということです。つまり、不可能だったと思っていたことが可能になったということです。これはUltimaker社の 3D プリンターだけではなく、すでに皆様が今使用しています他社の 3D プリンターでも実現できますので、ぜひ試してみてください。どこまで細かい造形が可能かというと、車種成形をちょっと考えてみていただきたいです。そのため、今まで、車種成形の部品の場合は、壁などの部品形状が薄く、細かいことが多いかと 思います。そのため、今までフィラメント材料を FF 方式でうまく接着せず、射出液に及ばないケースや形状があり、今までやっぱりそこがぶつかる壁として、大きな課題としてあることが多いかと思います。こちらの話をよく表すために、今回は 3D プリンティングの世界では誰もが知っているベンチのこのモデルの方でご説明をさせていただきたいと思います。こちらのモデルはネット上で無料でダウンロードできる標準の大きさのベンチモデルですが、ご存知でない方は、ベンチは 3D プリンティングのベンチマークとしてよく使われている 3D プリンティングのモデルです。でこのなぜ使われるかといいますと、やっぱり 3D プリンターの精度や性能をテストするためで、やっぱり役割として比較するものが必要ですので、こちらのモデルは特に FFF 方式の 3D プリンターでは欠かされないテストモデルの一つです。はい、でそこでちょっとプレゼンの方で比較をしてみますけども、Cura 4.13、以前のバージョンと比較してみたところ、このような結果になりました。詳細の方のご説明させていただきますと、レイヤーの高さは約 1.1 ミリ、プリントコア、ノズルに当たる部分が 0.25 ミリ、で、デフォルトのプロファイルセッティングを使用した詳細になります。今回使用のノズルは、実は弊社が提供しております一番最小で小さいノズル径になります。Cura のデフォルトの設定では、小さくなればなるほど、ベンチを完全に印刷することが難しいと、難しくなったことが判明しました。灰色の影に当たる部分が、壁が薄すぎてスライス、印刷ができないということを表しています。スケールを 20% まで縮小したモデルは印刷可能でしたが、縮小率が 15% 以下になってきますと、煙突の部分だったり、中身の舵の部分が、うまく造形できないという結果になり、10% 以下になりますと、ご覧のようにモデルの半分以上が印刷できないということになります。もしお時間がありましたら、皆さんのプリンターでもぜひお試しください。で、同じスケールの、同じ設定で 5.0 で確認してみましょう。同じプロファイル、ノズル径、プリントコアを使い、縮小率を 10% に下げても、すべてがうまく印刷可能だということがここで判明できるかと思います。大きさを表すために、次のこちらのビデオの方で、バナナの、横に置いてみました。こちらを見てみますと、実際、どのようにこちらの今回のテストモデルが小さいかっていうのが、拝見できるかと思います。はい、さて、このような微細な印刷を可能するのには、エンジンはどういったエンジンがあるのでしょうか。弊社は、スライスエンジンを、スライスエンジンを完全に再構築し、新しいツールパスの戦略を導入しました。Cura でスライスボタンを押すと、エンジンはプロファイルにあるすべての設定を使用し、プリント中に材料をいつ、どこに、どのように押し出しをするか、計算をすることになります。正直なところを言いますと、これまでの Cura では、固定された線幅で印刷が行われてきました。この線幅というのは、ノズルの大きさに導いており、印刷時にはすべての線が同じ固定線幅で印刷されることを意味します。大きなパーツの場合は実際、線幅よりもディテールの方が大きいので、大概問題はございませんが、モデルの方が部品がより小さくなってくると、薄いパーツを印刷するようになってきますと、これが大半の場合問題になってきます。 次のアニメーションの方を見ていただきますと、このアニメーションを見ていただくと、スライスを実行した後のCuraのプレビュー画面で、モデルがどのように印刷されるかっていうのがシミュレーションされます。赤い線は外壁、緑の線は内壁、黄色い色は内部を埋める箇所を表しています。黄色の内部の箇所の細い線はCuraで固定された線幅で埋められ、できるだけ調整をしようとするような仕組みになっています。しかし、実際これを印刷して納得できる範囲ではございませんし、実際強度を最大限には活かしておりません。これを実現するには、線幅を小さくするか、埋めるべき箇所に応じて線幅を調整できるようにする必要があります。で次の、こちらの映像を見ていただきますと、Cura 5.0 のスライシングエンジンは、先ほどお話しいたしましたが、新しいツールパス戦略を導入していますので、ツールパス、Cura が素材がどこでどのように押し出されるかっていうのを決定する、作業を行います。これは私たちが戦略的に可変線と呼んでいるもので、線幅を一定に固定して押し出させるのではなく、線が配置される必要であるエリアに応じて線幅を一瞬で認識し、幅を調整するということになります。この調整はスライスエンジンによって自動的に行われ、線幅も最適化され、今回表示している内部のエリアの線幅がよりよくフィットするように、結果、均一な印刷が保証されます。5.0 では、こちらのシミュレーションでも見ているの通り、内部が適切に埋められ、可能な限り最高の印刷結果を得ることがお分かりになるかと思います。こうすることにより、より写出成形に近い品質となり、見栄えも良く、強度も高いパーツができるということになります。はい。私も実はいろいろなスライシングソフトを使用してきましたが、工業レベルになってきますと、レイヤーごとに線幅を調整するっていうのを自分で行うこともあります。これが自動的に大半のモデリングのスライシングを最適化できるということは、かなり大きなメリットになるかと思います。今お話しさせていただきましたことを加え、新しい 5.0 のエンジンより効率的なツールパス戦略、再設計されたUltimakerのプロファイル、そして高いパフォーマンス設定により、Ultimakerのプリンターはより高いパフォーマンス設定により、Ultimakerプリンターより早い印刷時間を達成することができました。もちろんプリントするモデルにもよりますが、タイムラプスで Ultimaker Cura 5.0 と以前のバージョンのソフトウェアを比較したタイムラプスビデオがございますので、こちらの方で拝見できればと思います。すいません。ちょっとビデオの方がうまくいってませんので、ちょっとすいません。ここは飛ばさせていただきます。申し訳ございません。ちょっとビデオの方は後ほど、YouTube の方にも載っけますので、そちらの方でまた拝見できればと思います。はい。また、Cura 5.0 の、新機能により、これまでプリントできなかったアプリケーションを FF 方式でプリントで実現できるようになることが、今後の、プリンター出力により大きなメリットと、今まで、ちょっと、FFF 方式で、できずに、他のテクノロジーに移っていくケースっていうのはあるかと思いますけども、こういったアップデートがあることによって、その、ギャップをより縮めることができるということになります。はい、で、デザイナーが試作した部品や、写出成形部品は非常に薄い壁を持っていると いうことをお話しさせていただきましたが、この部品で、こういった部品では、デザインの複雑な部品を忠実にプリントすることができ、あらゆる種類の製品開発、プロトタイプやアプリケーションに理想的にあることが実感できるかと思います。で、今日の話にも、スピーカーの方でもありますけども、建設ではより細かい部品や薄い壁が重要となってきますけども、FF プリンティングの設計では、壁の最小厚さなど、守らなければいけないルールっていうのがたくさんあるかと思います。今回の新しいスライシング技術により、より薄いパーツを印刷することが可能になりますので、そういった心配っていうのがなくなってきます。つまり、FF のための設計や 3D モデリングカットを制作する制約が少なくなったと、制約がなくなります。もし過去に3D プリンティング FF 方式で実際試したことがあって、求めている結果が、得られなかったという方がいましたら、ぜひもう一度ソフトウェアをアップデートした上で試してみていただければと思います。今回の紹介のCura 5.0 は弊社のホームページよりも無料ダウンロードできますので、ぜひセミナー後確認してみていただいて、ダウンロードの方していただければと思います。後日のメールの方にもリンクの方を貼り付けさせていただきますので、見つけられない方はまたメールの方で探してみてください。はい。今回の Cura 5.0 の進化は、実はティム・ケプラーの論文と、弊社のUltimakerチームの努力で実現されたものです。はい。では、ゲストスピーカーの方に進めたいと思います。最初のご紹介いたしますユーザー様は、Ultimaker Cura 5.0 の初期バージョンを自前に入手したトム・ディクソンチームになります。トム・ディクソンさんは数々の賞を受賞しているデザイナーです。その独特なスタイルからキャリアを通じて革新的なツールを今まで採用してきました。2002年にロンドンで成立した彼のスタジオは、現在世界中で100人以上のスタッフを抱え、世界中市場のいろいろな家具や照明、アクセサリーのデザインを共同で制作している会社になります。では、彼らがどのようにアディティブマニュファクチャリングを使用しているか、ご覧になりましょう。
My name is Tom Dixon, and I'm a designer based here in London, England, and I have a company here which is atypical compared to other product designers because we do our own product development, obviously the design, but also the distribution and the communication of all of our products as well. So this company is structured a bit more like a fashion company than a design studio, but we also have an interior design facility. And we have a restaurant here in our retail shop in the heart of London. 3D printing has been around obviously for a while now, and it was the talk of the design community for a long time. We'd see the early machines and their outputs coming through, particularly in design fairs like Milan. We preferred modelling by hand for a while until the scale of the machines became bigger and the precision became better as well. But it's proved a kind of invaluable tool for us on so many levels. I started designing really by making things with my own hands, and then moved into almost factory production, and then moved into, like every other design studio, mainly computer-based design. And I got more and more frustrated with two-dimensionality of the digital world. So what was amazing when 3D printers came along was the fact that you could take those models out and make them physical models again. We use it on a wide variety of different tasks. We've used it for small batch production, so rapid manufacturing, as opposed to rapid prototyping. We've used it to make patterns for casting, for instance, so that we can actually use the plastic as patterns, whereas before you had to spend a lot of money getting very precise wooden patterns made. And we use it obviously for modeling full-size scale models or tiny models to explain to a customer or a factory what our intention is. But we're only starting to discover all of the possibilities, and we're going to start, now that we've got the machines here in the studio, also using them for making things like stamps for ceramics, back stamps, or for even printing, printing paper bags and things like that. So we're going to use them to actually make tools to do other things as well. We'd like to use Ultimaker because it's a very generic software that a lot of people know how to use. It's user-friendly, but also the machines are relatively affordable, and we're able to get moving very quickly. You don't need huge amounts of skilled expertise. And of course, because they're widely distributed, you can get the spare parts and you can get the filaments as well relatively easily, right? So there's something about being with a company that's got wide distribution and recognition that makes it easier for us to use the Ultimaker. Yeah, I mean, there's some pretty simple things that are much better now with the new software, specifically thin walls and things that seem pretty basic, but these really sharp points were previously impossible. So it's kind of nice to be able to move one step further towards making really precise, dimensionally precise objects, which we can actually use even in small batch production as components for lamps or other parts, right? So we've outputted for the community a chess set, and we've been able to really try and make some components. It's a kind of demonstration set, but also with a practical outcome of all of the different possibilities of the new software. Okay, so I think we're seeing really the very beginning. I mean, this technology seems quite mature now, but we're only seeing the beginning of the revolution in not so much rapid prototyping, but obviously rapid manufacturing. And as we become more and more able to print, for instance, metal at low cost or eco materials, which is increasingly a really strong need and narrative. We're going to be using these more and more for actual final products rather than prototyping. And also for things like unique pieces. So, now, particularly with NFTs, there's a lot of demand for algorithmic design, so each one different. There's a lot of demand for custom objects as well, for people that don't want what everybody else has got. And also tailor-made for specific needs. So I think we're going to be using it more and more. And of course, this is going to become really the manufacturing technology for the 21st century. Okay, thanks for watching our adventures in 3D manufacturing. I'm hoping to be even more part of this digital manufacturing revolution. Goodbye.
はい、トム・ディクソンから、さんからでした。実はトム・ディクソンさんのお店、渋谷区にございますので、ぜひ東京に行く機会がございましたら、ご覧いただければと思います。先ほどの事例で出ましたチェスボードなんですけども、そちらのデータも公開されていますので、後日のメールに、リンクを貼り付けておきますので、また、デュアルノズルのプリンターをお持ちの方でしたら、ぜひ試して印刷してみてください。次のゲストスピーカーはスティーブ・コックスさん。スティーブさんは自動車業界で30年以上の経験を持つプロのエンジニアです。現在は様々な分野の 3D プリント技術コンサルタントとして活用しています。私たち Cura 5.0 の機能をテストし、彼が 3D プリンティングで遭遇しているいくつかの課題を克服できるかどうかを確認するために、スティーブさんに Cura 5.0 のアクセスを提供しました。では、スティーブさん、よろしくお願いします。
Hi, I'm Steve Cox. I have my own company called AMFORi Consulting. My background is I worked as a professional mechanical engineer in the automotive industry for more than 30 years. But for the last 8 years, I've been involved with 3D printing and additive manufacturing. I spend time developing applications, showcasing methods of 3D printing, and helping clients adopt this technology. And one of the things I enjoy the most is exploring what this technology can do and how people can use it. Ultimaker and the Ultimaker 2 that I bought 8 years ago really started me out on what I've heard called a walk in the woods with additive manufacturing and 3D printing. It still ranks as one of the best decisions I've ever made because it works straight out of the box and it allowed me to concentrate completely on applications rather than just making the technology work. In whatever I do, I'm always striving to achieve the best possible quality output, and I'm sure many of you are the same. But those attributes of quality always stood me in good stead. So how do you create the best possible quality with the highest level of efficiency and the minimal amount of waste? It's something that I'm always keen to explore in the work that I do with 3D printing because I'm always wanting to present the best possible way of 3D printing to the clients that I work with. So that lean manufacturing mindset completely frames what I do now. I spend a lot of time when I'm designing and setting up 3D prints, and that often means spending time in the preview side of the slicing software to ensure that I know what kind of output I'm going to get and it's going to achieve the quality that I'm looking for. Thin walls and small features can often be challenging when striving for that kind of quality and efficiency in 3D printing. And sometimes the requirements of 3D printing can bear too heavily on the design. What do I mean by that? Well, maybe you're prototyping using 3D printing for a different method of manufacture. And the design requirements should be driven by the ultimate method that you're going to use to produce that part, not by the 3D printing side of things. Take as an example this design, which I've created using Autodesk's Fusion 360 and the new plastic design tools that they've just introduced into that software to make designing of injection molded parts more efficient. And those injection molded parts are the kind of thing that often use thin walls, clipping features and webs. In this example, the parts were designed around the rules for a 1.5mm injection molded plastic housing. That 1.5mm wall thickness for these parts presents some issues when it comes to 3D printing. 1.5mm isn't an exact multiple of a 0.4mm nozzle, if that's what you're using. It's also not an exact multiple of a 0.6 or a 0.8mm nozzle either. But those inefficiencies are dealt with by Cura 5. In Cura 5, the introduction of variable line thickness deals with those inefficiencies of creating that 1.5mm wall thickness. That's done automatically by the software and no user input is required to create those variable line widths. So let's take a look at that 1.5mm wall thickness. In the preview of the slice in previous versions of Cura, you can see that that 1.5mm wall is created from 2 outer shells, 2 inner walls, and a very thin line of infill. And in the corners of the part, some very small amounts of infill applied. Is that really efficient? Is that really the best quality? Is that really going to give you the best possible 3D print? Now let's compare that with the same part sliced with Cura 5. That same wall thickness now is being created by 2 very even outer shell lines and 2 very even inner wall lines. No thin infill, no messy condition in the corners. That has to be much more efficient because we're talking there now about using 4 toolpaths instead of at least 5 in previous versions of Cura. It's a similar story when we look at these small clip features that are holding the 2 parts of the housings together. Again, let's look at it in previous Cura. You can see that the clip is being created by an outer wall, an inner wall, and again, a small squirt of infill in the middle of the clip. Let's compare that to Cura 5. In Cura 5, you can see those same clip features being produced by using 1 single outer shell line and 1 single inner wall line. Again, those clips are now being created in a much more efficient manner. There's an overlap condition that I've created in this design that you can see in this image between the upper and lower case halves. With this overlap, there's a 0.25mm gap between the 2 overlap conditions to ensure there's no interference when the 2 case halves are brought together. That means that we end up with a very design-driven dimension of 0.625 millimeters for these overlap wall thicknesses. So let's take a look how previous versions of Cura deal with that 0.625 millimeter wall thickness. You can see here it's doing it by creating two very uneven shell lines. Let's contrast that to Cura 5, where you can see that same wall thickness is being generated using a single shell line. That's one toolpath instead of the two toolpaths required in previous levels of Cura. The uppercase half has web features designed into it, which are typical of injection moulded parts of this type to increase the stiffness of an open design such as this. In this case, those web features are 0.75 millimeters wide. And that's a rule that's driven by the injection moulding side of things, where you need a web thickness of half the main wall thickness to ensure that you don't get any visible sink marks on the outer surface of the part. So you can see here the previous levels of Cura create those webs using two uneven shell lines, and also there's some non-uniform infill lines going on that you can see in this preview image. Let's contrast that to Cura 5, where those webs are created using two even shell lines. Again, massively improving the efficiency of the 3D printing and also hopefully the quality. All of these improvements contribute to a better, cleaner, higher quality 3D print. The efficiencies in toolpathing created by variable line width control bring about a significant reduction in 3D printing time. In this example, the print time using Cura 5 for the lower casing was 17% less than when the same part was sliced using Cura 4.13. And for the upper casing, the print time reduction was 15%. That's a really beneficial time improvement, and one that really fits well with my desire to create the most efficient 3D printing experience with the highest possible quality. Oh, remember that 0.625 millimeter wall thickness? How did that turn out? Well, let's take a look. That's pretty impressive, and that's the kind of quality that I'm looking for in the output from my 3D prints. So all of the things that we've seen in this presentation show how Cura 5 contributes to better quality printing with higher efficiency. That for me is a perfect combination. And the great thing about Cura 5 is that it does this for everyone, not just for those people using Ultimaker machines. So you can see here that these parts were produced on an Ultimaker 3 that's 5 years old. Not the latest S5, not the latest S3. And that shows that Cura 5 delivers excellent results no matter what the age of your machine. I hope that's given you a really interesting insight into what you can expect from this very latest, exciting version of Ultimaker Cura. Thanks for listening. Enjoy the rest of this showcase.
はい、スティーブ・コックさんからでした。5年以上前のプリンターでも結果が変わるということは、いかにどれだけソフトウェアが大切なのかを実感しますね。Ultimaker Cura では、より細かい部品の印刷が可能になり、特に建築家にとって複雑な形状を持つ素晴らしいモデルを制作するのに便利な機能です。最後は建築デザイナーのデザイナー、ファブリケーター、教育者であるカルロス・カステロさんにご紹介させていただきます。以前はボジョグ・インゴーグループに所属し、数十年のデザインチームを、数十年間デザインチームの方を指導し、最初の 3D プリントファームで何千個のモデルを制作されたということです。それでは、カルロスさんから Ultimaker Cura の建設的な可能性について詳しく話してみます。
So I'm Carlos Castillo, currently a professor at Parsons New School. Becoming a fabricator for me wasn't necessarily planned, but it was always a part of my life. My dad and I would build a lot of things. I kind of fell back in love with fabrication once I went to architecture school. From the beginning, the idea of 3D printing and just having something come out of nothing up to this day really fascinates me. I started working for Tristan Al-Haddad right out of school. He's a professor of architecture and a sculptor back in Atlanta. I moved on to New York. I got the opportunity to work for Raphael Vinoli. Very traditional, a lot of hand techniques. From there, I moved on to working for Bjarke Ingels. Bjarke Ingels Group, or BIG as most people know it. Models for them are very important. Every single idea needs to be accompanied with a model. If not, it's not valid. I helped develop their first 3D print farm. Started with 2 Ultimaker printers, and after like 2 years, we ended up with 11 machines. I started working at the new school and sort of take all of that accumulated knowledge and now trying to teach my students to use technologies in their advantage. Models validate designers' ideas in a much more convincing way. One of the things that we're able to do now is to capture a lot of small details in even smaller scales. Cura 5.0 has allowed us to capture way more resolution. Being able to produce very thin walls, it increases the speed of output. What I appreciate the most about the UI of Cura is their preview, where I can really understand how the material is being deposited. One thing that I've enjoyed a lot is the lighting infill feature. It saves a lot of material. The Architopology project is a collaboration between myself and Ultimaker. We're producing a bunch of different towers. You'll be able to download and be able to slice and modify architectural models from this imaginary project. Keep following Ultimaker. We will make an announcement fairly soon.
はい、カステロさんからでした。次は、弊社の、プリンター、メタルプリンターに関してなんですけども、弊社のプリンターはメタル、ステンレススチールの316の素材を造形することができます。BAS 社の、オルタフューズフィラメントを使用することで、プラスチックと同様の機器で、メタル部品の印刷が可能です。サポートの箇所と部品の側面に対してもセラミックの素材が入ることにより、サポート除去も手軽です。では、本社よりプロダクトマーケットのマレット・ホフマンさん、事業開発マネージャーのアンドレア・ガスペルニーさん、および BF 社の事業開発マネージャーのトバイアス・ロドミエルさんからの説明をご覧ください。
And here you have it, a metal part sliced with the new Ultimaker Cura 5, printed on an Ultimaker and post-processed into a final metal part. Hi everyone, my name is Marit Hofmans. I'm a product marketeer at Ultimaker, and in the next couple of minutes I would like to talk to you about metal FFF 3D printing. For those of you familiar with metal printing, you may know that printing metal parts with Cura and an Ultimaker printer is already possible. However, with the release of the new Ultimaker Cura 5.0, we take a big step forward in making metal FFF printing easier and more successful. This means that you can create high-performance parts with the advanced properties that metal has, such as an extremely high strength or temperature resistance, allowing you to print applications that are often not possible in using plastics. So, how do we achieve this with Cura 5? As explained earlier by Mariska, the new Cura 5 comes with big improvements for creating detailed and thin parts. This is not only relevant for plastic parts, also metal applications will greatly benefit from this. With the new Cura improvements, metal parts with thin walls will benefit from an increased wall stability. This is very important for these parts because it will help to minimize the chance of delamination during the post-processing steps, and thus it will contribute to a successful end result. But next to the general Cura 5 improvements that metal parts will benefit from, we're adding more. We will introduce specific features and settings for metal printing that Ultimaker users that print with BASF Forward AM UltraFuse 74pH and 316L metal filaments will directly benefit from. These new features will make the slicing workflow for metal printing easier and give you more control over the outcome. So, what are these new features exactly and how do they improve the printing of metal parts? For this, we will move to our experts, who both have been involved a lot in metal FFF 3D printing. Welcome.
Sure, Marit. Thanks for the introduction. My name is Andrea, and I'm part of the product management team and leading the metal printing initiatives within Ultimaker. Here with me today is Tobias.
Hello, my name is Tobias. I'm the business development manager for our UltraFuse metal filaments working for BASF Forward AM.
No doubt that producing metal parts by standard FFF technology is coming out strong as a high interest topic from the 3D printing adopters globally. For those that are still not familiar with the process, extrusion-based metal printing rely on the processing of highly filled metal filaments, like the ones offered by BASF Forward AM, to produce a green part that is subsequently debinded and sintered to finally obtain a near net shape and full metal part. The sweet spot for this technology are the thousands and thousands of customized tools, manufacturing aids, and obsolete non-critical components. When operating the technology within this sweet spot, user can potentially realize cost savings up to 90%, lead time reduction up to 70% for small series. However, Metal FFF on open systems like Ultimaker is still in its initial stage of development, and more is needed to reach the level of readiness to fully enable a flawless and reliable metal parts printing process. The path towards the needed level of process performance and quality involves development on all fronts: hardware capabilities, material, but also software capabilities. And here today, I'm really in particular referring to the print job preparation by means of a slicing software like Cura. Many of the benefits that the introduction of the new engine in Cura 5.0 are definitely applicable when dealing with printing metal parts. Being able to print sharp corners and stable thin walls or features are the major area where the development of the Cura engine was focused on in response to some of the major blockers that we have identified while developing customer application. So, Tobias, what is Cura 5.0 bringing once you are developing application with customers?
Thank you, Andrea, for giving me the opportunity to talk about our use cases. So with the new CC 0.4mm print core, for us it was a natural step for new features and a new way to print thin walls. Thin feature can suffer from void and small gaps, which reduces the stability and integrity of the specific area. Not only in the debinding and sintering process, also in the final metal part, these defects would still be there and could lead to an undesired failure during the application. So printing small details is a very well-known and good application for 3D printing and is now more accessible with better performance. For example, vertical or horizontal holes and of course labeling of parts.
Another source of inaccuracies and part failures was identified by customers when having actually to modify the dimension of the part that they were about to print in order to accommodate the shrinkage of the part during the binding and sintering. Tobias, can you explain why you need to control the part scaling prior to starting the print and why it's so convenient actually to have it in Cura 5.0 and it's already done automatically?
Yeah, let me explain this to you. The new automatically scaling of the parts in Cura 5.0 is an important step towards the reduction of complexity along the process chain. I know it seems to be mysterious for quite a lot of people, but I can tell you it's not scaling. The part prior to printing is not witchcraft. During the sintering process, the metal powder starts to solidify by diffusional processes. The empty areas of the former binder vanish and the volume contracts, leading to a shrinkage. To compensate for this volumetric contraction, the parts need to be scaled prior printing. This corresponds to 119% in X and Y and 125% in the Z direction. Besides the filament composition, which is critical for the shrinkage, also the part geometry can have an influence on the accuracy. Nevertheless, sintering technologies are always referred as near net shape, and an automatic scaling function will help customers dramatically to overcome the first hurdle when starting to print metal parts.
Well, thanks, Tobias. Another milestone towards the development of the Cura 5.0 engine capabilities was achieved when Ultimaker and BSF Forward AM started a joint application development with Liber components. In the framework of the collaboration, one category of application that was identified as a target for being produced by Metal FFF were the customized assembly tools, like this one that you can see here. This is a part that fits within the 10 to 12 centimeter size, is a non-standard off-the-shelf part with the need for tolerances within 0.3, 0.4 millimeter over the whole part, and a limited amount of units that needs to be produced per year. Metal FFF was therefore selected as the manufacturing technology to do this cost out, but also to reduce lead time and the whole logistic around the sourcing of this part. Indeed, designing tricky assembly tools requires many efforts and time with conventional manufacturing methods. One of the major challenges that this part was featuring with the former engine version we were using in the past was the fact that the part was showing distortion along some of the thin and high height over width areas after sintering. Tobias, from a processing perspective, which is the origin of the distortion that we have seen in this application?
So, as far as I could understand it, it's based on the crystalline character of our binder, which introduces internal stress along the thermal history of the printed lines in the part, which could also be seen in the phenomena like warpage. In the green state, these stresses are stored, but the matrix resists to the deformation. So during the debinding steps, the matrix is removed and is getting weaker, and the part starts to distort, and the shape is transferred into a full metal part.
So actually, by understanding, therefore, the origin of this distortion, BSF Forward AM and Ultimaker R&D identified in the introduction of the alternate wall directions feature in the Cura slicer a solution to remove part distortions during the sintering process. This feature is now present and used as default settings in the new Cura 5.0 when using both UltraFuse 174pH and 316L print profile, giving its key role and the high number of parts and design that requires the alternated wall direction use during print job preparation. As a proof that this new feature is relevant for a broad number of parts, Tobias brought a part today that relates very well with the challenges that we were describing before. Tobias, what is the story behind this part?
This part comes from our very first customer journey, where we did not succeed to meet the desired tolerances, even we did everything right from the state of the art at that time. As you can see, we have high and thin walls, and in the sintered state, it's distorted. As you might remember, you gave us the opportunity to test the feature of alternating wall directions, and it worked on the first print. Since that, we knew it is a mandatory way of printing, which is needed for our material and post-processing.
To conclude, what we have shown today is the beginning of Ultimaker journey into the field of metal printing. As you can see, we are strongly engaged with our ecosystem partners and representing BSF Forward AM here today, thanks to Tobias. And we will extend further the capabilities of our Cura engine and hardware to enable users to extend even more the range of metal parts and get an even higher control from printing step to the final sintering step.
Thank you, Andrea and Tobias, for all these interesting insights. So, to summarize, this means that with the new automatic scaling and alternate wall directions feature in Ultimaker Cura 5.0, we will make metal FFF printing easier and more successful. And, as Andrea already mentioned, this is just the start. We are happy to announce that we are working on an exciting new metal 3D printing solution that will use Ultimaker and Cura to unlock more industrial applications. We will reveal more details about this in the upcoming weeks and months. If you're interested and want to be the first one to hear more about this, then please go to ultimaker.com/metal and register yourself for updates. Now it's back to Jürgen for some final remarks.
はい、メタルプリンターのご紹介でした。メタル印刷の可能性が弊社のようなプリンターでできるということにより、いわゆる可能性をさらに引き出して、さらに可能性を生み出すことだといいですね。今回のショーケースは以上となりますが、皆様とお別れする前に、最新ニュースがございます。もうご存知の方いらっしゃるかと思いますが、弊社オルティメーカーがアメリカの、メーカーボット社と、合併し、新しい会社になります。まだ正式な契約は成立しておりませんが、来年に向けて今後のハードウェアおよびデジタル機能が、上場する見込みですので、メーカーボット、見込みです。メーカーボット社は、シンキバースのオーナーでもありますので、そちらのデジタルプラットフォームが弊社の元と融合することによって幅広いユーザーへいわゆる観点から提供できるシステムになると思っております。ぜひ今後ともこちらの移行に対してのサポートよろしくお願いします。今日ご紹介させていただきましたコンテンツおよびショーケースのレコーディングは後日のメールで再度ご紹介させていただきますので、皆様今日はご参加いただきまして本当にありがとうございます。またご質問等ございましたら、弊社のサポート、Facebook やLinkedIn、あとブルーレイ、弊社の総代理店である、ブルーレイ社のウェブサイトの方へ、お越しいただいて、質問されても、いいと思いますので、お気軽にお問い合わせください。今日はちょっと、長くなりましたが、1時間近くの、お聞きいただきまして、誠にありがとうございます。ではまた今後ともどうぞよろしくお願いいたします。